Okay, so this is net example 3, and I think I've got it up there correctly. The first thing we want to do with this is we want to reduce it to something we can solve. So 5 and 7 is easily 12. 12 and 11, those guys are connected end to end, right? So this end, both ends connected, both ends connected. So those guys are parallel, right? So that resistance is 1 divided by parenthesis 1 divided by 12 plus 1 divided by 11. And I'm going to store that in alpha A. That's my first one. So this guy here is 5.739 ohms. And that's my value A. Like that. And then these guys, the 2, the 3, the 5.739 and the 3 are connected how? They're just end to end, right? One end's connected to this guy, one end's connected to this guy, one end's connected to this one, right? It's when both ends are connected that they're parallel, right? So these guys are series, so that's going to be 2 plus 3 plus A plus 3. Okay, so if you're calculating along with me, A is where you stored this, and we all know how to store this, don't we? We go store, and with the TI-83s, annoyingly, every time you store, you're going to store it in some alphabet location, but you still have to type alpha to make sure you really mean it. Okay? So I'm going to store this guy in B. Right? So that equals 2 plus 3 plus alpha A plus, whoops, I'm subtracting. Sometimes I subtract, right? This thing has all the paint worn off of its keys. Plus 3. 2 plus 3 plus A plus 3 storage alpha B. So that's 13.739, right? And you can look at the bottom there. If you look at the little numbers there, I had a spreadsheet. When I solve these, I use spreadsheets because spreadsheets are just so much fun, right? So you could see that I'm getting the numbers that are in the spreadsheet. These must be the first 3 numbers that aren't assigned anything, right? That's a good way to check, right? And then this guy, this one resistor, this 13 point, and this is B, right? That one resistor right there is connected to this resistor. How? They're parallel to each other. Both ends are connected here. On the other side, both ends are connected. That's the definition of parallel, right? So that's going to be my C, right? And that's going to be 1 over 11 plus 1 over B, where B is this number, right? So 1 divided by parenthesis 1 divided by 11 plus 1 divided by alpha B. And I'm going to store that in C. Whoops. All right, I'm quitting. Alpha C. There you go. 6.1089. Yeah? Are we good? Now we can recognize the circuit, can't we? Yeah, this is a circuit that we can solve. This is a simple series circuit, isn't it? Yeah? It's a 3, a 6.1089, and a 5 in series, and that's easy, isn't it? Okay? So we solve that guy. I'll get the blue pen of solving out. Okay? The blue pen of solving. Okay? The current in that circuit is 19 divided by, and this is what you do with a series circuit, right? 3 plus C plus 5, where C is 6.1089, right? I've stored that, right? So the current is 19 divided by parenthesis 3 plus alpha C plus 5. And I'm going to store that in alpha D. So that current is 1.34666 amps. I remember this from Friday, right? And that also, by the way, is the reading on this ammeter right there. Okay? That ammeter has that current going through it. Right? If there was a voltmeter across these guys, and apparently there's not, we would just use that and go I times that R, but there it is, right? So there that is, okay? And then the only other thing we can solve in that simple series circuit is we can solve for V1. V1 is across not just the 11 ohm resistor, it's across this whole mess. It's across 6.1089, right? So V1 is equal to this thing here, which I've stored in D. That's my D, right? So it's equal to I times R. So for me, that's like D times, what is that guy, C, right? DC Comics or something like that, right? Okay. And those numbers are 1.34666 times 6.1089, right? So I'm going to go this guy times alpha C. And I get that voltage, V1, is 8.2267 volts. And I'm going to store that in E. Don't whistle. Okay? Yeah? Are we good? So I'm on letter E. Eventually we're going to get to like F and G and all that stuff, right? Okay. Are we good so far? Because I'm about to get rid of the 3 and the 5 ohm resistor. Yeah?
Why is the resistance on the V1 6.1?
Because it's attached to this whole thing. From here to here, the resistance we determined was 6.1089. Yeah, but it doesn't matter because it sees this whole resistance. The resistors add together the way we learned last time, right? Okay?
Why don't the 3 and the 5 have any?
They do. The 3 and the 5 and all these guys, I'm sorry, these guys added in here, right? In C, all of this stuff went in to make C.
Yeah, no, I understand that, but why doesn't V1, why is this?
Because V1 is connected to the same piece of metal that's connected to all of these resistors is connected to the right. It can't distinguish between just 11 and, right? I'm going to pass this Stevie word. I don't know. Okay, so now I'm going to pop the circuit, and this one is, by all counts, a double popper. Okay, so I'm going to save room for the second pop, but the first pop is this. I've got a battery of 8.2267 volts, sorry, right, or whatever I've got in letter E, right? Okay, and that is attached to 11, right? And that is attached to 3, and then there's a 5 and a 7, right? And a 11. Is that right? 11 and a 5 and a 7 and a 3 and a 2 and a 1. We're missing this guy here, right? Just kidding, a 3. And this guy's 11. Do I have that right? I wish I had like some super smart board technology where I could just sort of grab the thing, and I think I've got that right, don't I? Okay, so now I can start picking stuff off on this guy. Let's get the blue pen of solving here. First off, there's an ammeter right here. Isn't there an ammeter? A2 is right there. So I can find that current. A2 is easy. It's just 8.2267 divided by 11. I think that's a throwaway. I don't think we're going to use that for anything. So I'm going to go this guy divided by 11 is 0.74788. Is that number in there? Did I get that right? There's no sense going on if I get something wrong, right? Okay. Then I can go and I can pick off this side of the circuit, right? Isn't this side of the circuit independent from this one? Aren't they both connected to the battery? It's a parallel circuit, right? So I can do this current. So I just did this current, right? Now I can do this current here, okay? And that one's going to be a little more complicated. That's going to be, the current is 8.2267, right? Or the thing I have stored in E divided by 2 plus 3 plus, and then what is this guy here? This guy is A. Wasn't that A? A plus 3. Right? And A is this guy here, 5.739.